Welcome back to computer science. We've got a lot to recall from yesterday. What were we doing? I think we finished counting the day before, so it would have been lists, okay. All right, lists. They are mutable. There are certain list methods we can use to change lists. We can use a dot notation. So you say list name dot method. So this method would be append. Append will add on a new element to the end of the list. An element is an item in the list. Okay, let's take a step back. A container is a data structure that contains references to other objects, and it can contain different types of objects. It can contain strings, variables, literals, floating points, etc. Even booleans probably. So a list is a container that is created using brackets, and an index is the an integer that denotes the location of an element within a list, and the first item in the list is 0, the second item is 1, index 0, index 1. Okay, you can use kind of like an expression where you say list name bracket index number bracket, and that will call, or that'll evaluate to the item in that list with that index. Index expression, maybe? Element index expression, something along these lines. So then we got the methods. We already talked about append. List name dot pop. Within the parentheses, you're going to denote pop. You're going to denote the index that you want to remove, and then remove you will denote a value or an object within the list, and it will remove the first item. I think reading from 0, 1, 2, 3 that way, ascending, the first item that matches the item value that you denoted in the remove method. So we had these two things: sequence, right? A list is a sequence type, so is a string. Sequence types have order, specific order, and they can be broken down into like little characters or objects, something along that line. Sequence list functions versus sequence list methods. Somehow they're related. They're both built into Python. The methods I think of as the dot notation ones, like the three we already mentioned. Functions are basically, it seems that methods will actually change the original list. It will, because it's immutable, it will change it. Whereas functions won't change it, but they'll use the list to evaluate some other value, such as the length of the list, len, min, finding the minimum value, max, finding the maximum value, index dot list dot index, which will find the first item in the index, I believe. Sum, if it's numerical values, that will be a list function that outputs the sum of the numbers. So I think that's basically everything. All right, list basics. Creating a list, container, a data structure used to group related values together. Okay, groups related values together. Contains references to other objects instead of data. It isn't, yeah, okay, references. List, a container that contains a sequence of variables or literals and or literals created using brackets, element, a list item, lists are mutable, lists are objects, and a list's value is a sequence of references to the list's elements. Each element is an object. Index, but it doesn't contain the objects, it contains references to the objects. Index, an integer that specifies an element's position in a list. Indexing expression, that's what I was trying to say. List with the brackets and I'm. Indexing expression. Adding and removing the list elements. Method, instructs an object to perform some action. Specified by providing the object name followed by a period and then the method name. Append, list method, pop, remove, good, all that's good. Sequence type methods, functions built into Python, good. Sequence types, right? Append, pop, remove, dot notation. Sequence type functions, also built into Python. Don't need dot notation. Operate on given sequence. Doesn't change or alter original sequence. Len, okay, concatenating two lists. That's what I forgot. And then list.count. And then you specify what value, and it will tell you how many of those values are in the list. So, all right, that was a lot of recall. I'm gonna jump back into learning more, and then I'll be back to recall what I learned in a little bit. Okay, so we continue working with more lists. We were just actually doing mostly practice exercises with the len function, the sum function. So sum divided by len will get you the average of the list. I learned that functions actually come before everything else except for parentheses and precedence, in the order of precedence. And surely there's something else. Concatenating lists, concatenating or adding elements, subtracting elements from each other. Yeah, just some exercises. So we're very close. We'll be done with this list unit, or unit in the next session, and then we'll be into binary numbers, which is a really quick session, and then we'll be done with lecture 12, which is due tomorrow. So pretty good timing. Am I forgetting anything? Okay, yeah, we got 20 more minutes today for computer science, and then we're done for week 6. So talk to you in a bit. All right, welcome back to computer science. Quick overview of what we were doing earlier. We're continuing with lists, so I'm gonna keep working. This is the last session of the week, so I'm gonna keep working for a little bit longer, and then we'll call it. I'll be back to recall what I learned. All right, guys, we finished the lecture 12. We finished the unit on lists, then we started and finished the unit on binary digits, or binary numbers. So binary numbers are really numbers using base 2. Decimal numbers are numbers that were typically used. We typically use their base 10. Yep. We covered that last semester. I'm pretty comfortable with it. Okay, I thought it was raining out. It noted in this binary digits unit that in many programming languages, let me take that back. Variables are only represented with so many bits. They're only allocated so many bits, so they can only store numbers so large in most programming languages. However, in Python, if a number exceeds the allocated number of bits, it can assign more bits to that variable. And so there's really no limit on number size, it seems, in Python. It's except for when you hit memory limits. So I'm sure that's in working memory or RAM because these are variables that are being stored. I would assume so. Is it memory or is it? Yeah, I think it's in RAM. Anyway, that's it for this week. Week 6 is through. I'll see you tomorrow in week 7. See you then.